All right, hi, we're here with Rita to talk about some multi-step problems. Ready to go?
Yes.
Okay, so we're going to look at some real-world problems, some percent examples, and then an example with negative numbers, okay?
Okay.
All right, so let's look at a real-world example. What we're going to be doing here is just looking at problems that you might encounter in your real life and just how to solve them. It might not seem like we're using equations. You're kind of using equations in your mind, but let's take a look. Okay, and there's always some strategies that you can use. I've listed a few here. So one is when you get these word problems, draw some pictures to make sense of it, okay?
Okay.
And then write in what you do know into the picture and what you don't know. And then finally, you always want to take a complicated problem and break it down into its steps, and then it'll make sense to you. So let's take a look at an example. Okay, you want to center a couch against a wall in your house. The couch is 2.2 meters long and the wall is 4.8 meters long. How far from the end of the wall should the couch be? Okay.
Okay.
So if you were going to draw this, how would you draw it? What would you want to draw here?
I would draw the length of the wall
Okay.
and the length of the couch
Okay, and where would that couch be on the wall there?
in the middle.
In the middle. Okay, so something like that?
Yeah.
Okay. All right, so now we've drawn the picture. Now we always want to use our strategies. So here we've said that we're going to write in what we do and what we don't know into our picture here. So what could we label here in our drawing?
The length of the couch we know is 2.2.
Okay, so we could write that in like that?
Mm-hmm.
Okay, what else can we label?
The length of the wall is 4.8.
Okay, so could we write that in?
Yeah.
Okay, good. So now what is it that we're looking for?
Well, we want to center the couch, so how far is it from the end of the wall?
Right, that's what the problem asks us to find here. How far from the end of the wall? So that would probably be either here, it didn't say which wall, or over here. What do we know about this distance and this distance, though?
They're equal.
They're probably equal, right? Well, they would have to be equal because the couch is in the middle. So what we're looking for is those two distances there, or one of those two distances, right? Okay, so break it down for me. Like, how would you do this now?
Well, let's see. I would get 4.8 and I could subtract out 2.2.
Okay, good. So what would that do for you if you take this whole 4.8 and subtract the 2.2? What would that do for you? What would be left over?
It would give you the two distances on
Okay,
either side
yeah,
of the couch.
the total space, this one
Yeah.
and this one together. Okay, so let's go ahead and do that. The total extra space would be 4.8 minus 2.2. What would that be then?
It would be 2.6.
2.6. Okay. Okay, great. So now that's both sides of the couch. So what do we have to do then with that 2.6 in order to figure out what one side would be?
Divide it by 2.
Okay, so we could say that half of that amount would be 2.6 divided by 2, which would be
1.3.
1.3. Okay, so then what does that mean for our problem here?
That it's 1.3 meters to the wall from the couch.
Okay, so the couch should be 1.3 meters from the end of the wall. Does that make sense? Okay, so basically all you're doing is you're slowing your mind down and you're just going one step at a time, draw a picture, put in what you do and don't know, and then go ahead and just calculate one step at a time and you can get to your answer, even with a complicated problem like this. Okay, so let's go ahead and circle that answer and let's look at a percent example. So now, same thing here. You always want to try to break these problems down into their steps. So let's look at an example. The population of squirrels in a park is 90. Angelica, the park's chief ranger, believes the population will increase by 10% this year. Okay, does that make sense so far?
Okay, yeah.
Okay, so by how much will the population increase? Okay, so what would you do to figure that out?
Let's see. Well, we know what the starting population is.
It's 90, right?
And then it's believed that it'll grow by 10%.
Okay, so how much would that be? What calculation would we do?
10% of 90.
Okay, so if we were to do that calculation, 10% of 90, how would you go about doing it, taking a percentage there?
I would do 1/10.
1/10, because 10% is the same as 90? Yeah.
Yeah.
So we can do this in a few different ways. The one way that we could do it is what you just said, 1/10 times 90. You could also change the percentage into a decimal and do 0.10 or 0.1 times 90. And all of these are the same as 10% of 90 or 10% times 90. Usually when we have the word of, it means multiply. So, okay, so any way you do it, let's do your method. What is 1/10 of 90?
9.
9, okay. So the increase is going to be 9 squirrels, right?
Right.
Okay, now if we follow that up with another logical question, how many total squirrels will there be with this increase? What calculation would you do there?
I would add 90 plus 9.
90 plus 9, and what would that be?
99.
99, okay. So there will be 99 squirrels at the end of the year if the ranger was right. And basically the way that we got to that is, again, just slowing down and taking it one step at a time, just breaking that problem down into its individual steps. Okay, now let's do an example with negative numbers over here. Here, same thing, we're going to break our problem down into steps. You and 4 friends own a business. Together you decide to close the business and divide the cash and the debts equally. The business has $26,000 in cash and $32,000 in debts. How much does each person get? So it looks kind of complicated here. So we're going to break it down into its parts. So let's first say, how much does the business have? So how would you calculate that?
Let's see. Well, it has $26,000 in cash, but it has $32,000 in debts.
So how would you make a calculation to get to one number there?
I would say 26,000 minus 32,000.
Something like that?
Yeah.
Okay, good. So then let's go ahead and do the math there. What is 26,000 minus 32,000?
Negative 6,000.
Negative 6,000. So the business has negative $6,000. Does that make sense?
Yeah.
Okay, good. So that's the first step here, is to figure out how much the business had. And now what do you need to do to figure out the rest of this problem? What is the problem asking again?
How much does each person get?
Yeah, so how would you take that negative 6,000 and get to that step of how much each person gets?
I would divide it by the number of people.
Okay, good. And what did the problem say as far as the number of people?
Me and 4 friends.
4 friends. So you and 4 friends. Oh, so how much? What's the total number of people?
5 people.
5 people. Okay, so if we then said, how much does each person get? If we say negative 6,000 divided by 5, would that make sense?
Yeah.
Okay, and what is 6,000 or negative 6,000 divided by 5?
Negative 1,200.
Negative 1,200. Good. And what does that mean for this problem then?
It means that each person would have to pay.
Or has
their
a debt of how much?
Negative 1,200.
Yeah, so each person will have a debt of $1,200, right?
Yeah.
Lucky you guys, but still, you can figure out using math how to break this problem into its part and divide up this business equally, okay? So what have we been practicing here? Did we use any variables in any of these problems?
Oh.
We
no.
could have. We could have assigned a variable for this unknown here and for the squirrels and for the amount, but we didn't. And this is just a way to show you that you can solve multi-step problems in the real world by just thinking through it logically, following your strategies of drawing pictures, writing stuff in you don't do and don't know, and always, always, always break the problem down into steps, and those complicated problems will usually form into a series of pretty simple steps. Make sense?
Yeah.
Okay, very good. Good job.